Hey guys, here's the review for Spiral 13. First up, we've got the quadratics and exponent section, and here we just have some exponent rules. First thing I'm going to do is take care of my exponents on the outside, then I'll deal with the stuff on the inside. That becomes 3 to the negative 2, x to the 4 to the negative 2, 4 times negative 2 is negative 8. So that's x to the negative 8. 2 to the 3. X to the 6 to the 3 becomes x to the 18. Okay, I'm going to combine my x's first, and then I'll deal with some other things. So we got negative 8 and 18. I'm going to add those together. Becomes x to the positive 10. 3 to the negative 2 is the same as 1 over 3 squared, or 1 over 9. And 2 to the 3 is going to be 8. If I were to neaten this up, by the way, this is done, but if you wanted to neaten this up, you might write this as 8 x to the 10 over 9. Here we're looking at some exponent rules involving some division of things at the same base. First off, let's reduce my numbers. 4/38 turns into 2 over 19. Then let's deal with my x's. We've got a 2 and a negative 5 being subtracted. That turns into x. 2 minus negative 5 is positive 7. Then we've got y, and y to the 1 minus negative 13 is going to be y to the 14. Then we've got z to the negative 8 over z to the 11, negative 8 minus 11. That's these guys, is going to be negative 19. Only thing I have to do is move the z to the bottom, but let's neaten this up. 2x to the 7, y to the 14, over 19, z to the 19th power. Now we got some polynomial basics. We got to do some combining of like terms here. We've got 2x to the third minus negative 16x to the third is positive 18x to the third. We've got 2x minus nothing over there, so that's a plus 2x. Negative 5 minus 2 is going to be minus 7. We've got minus x squared. You don't need to do this, but if I wanted to write this in order of decreasing degree, 18x cubed minus x squared minus 7, plus 2x minus 7. Oof, almost messed up the order there. Now we got some multiplication. If I see multiplication here, this has to be distribution. So we're dealing with 6x to the 4th minus 45 x to the third plus 10x squared minus 12x to the third plus 90x squared minus 60x. Let's combine some like terms. Nothing for my x to the 4th. Minus 45 minus 12 is minus 57 x to the third, and that's those two. Plus 10 plus 90 is plus 100 x squared, and then minus 60x. That's my final answer. All right, we've got to sketch a graph of a polynomial. This one has lots of multiplicity going on. First thing I might do is identify my x-intercepts. For 5x minus 4, I'm going to say 5x minus 4 is equal to 0. That means that x equals 4/5. And with that cubed, we called that a drag here. So that's somewhere like here, and I'm going to label that with the word drag because at that point our graph's got to look something like this, or maybe the flipped version of that. Next parentheses, x minus 3 equals 0. That means that x equals 3, and because of the squared, we're dealing with a bounce. All right, so at 3, we have a bounce. And finally, we've got x plus 3 equals 0. X equals negative 3, and because of that squared, it's going to be another bounce. This is going to be a weird graph. So negative 3, we got another bounce there. So that's my x-intercept. Look at my y-intercept. I'm going to plug in 0 for x. So we've got 0 minus 4 is negative 4 to the third. Oh, this is going to be awesome. Negative 3 squared, positive 3 squared. So we're dealing with negative 64 times positive 81. And I'm totally doing this in my head, not looking at a calculator. So negative 64 times positive 81 is negative 5184. So negative 5184. Okay. And just to make sure that we are on the right track, we've got 7 total powers, so my degree is 7. We've got a positive leading coefficient because none of the x's are negative. We know in general the shape probably should go something like this. So let's make sure that works. I'm going to go from my y-intercept up here, and there's my drag. That's not quite hitting the point I wanted to, but that's about as good as I can get based on how close these points are together. I'm going to go up. I'm going to bounce off the x-axis and kind of go up like that. This is looking very pretty right now. I'm going to go up. I'm going to bounce off and kind of go like this. Okay. End behavior, f of x, otherwise known as y. As I go to the left, y is going down. We could say negative infinity because we're going down to the left. That's what those symbols mean. Or you could just say falls to the left. You could say as x goes down, y goes down. And we can use the same type of reasoning for the right side as x goes to the right. Y is going up, so we're going to say that we're going towards infinity. And again, if you'd rather write down to the left, up to the right, falls to the left, rises to the right, any of those things are fine to write. Your graph should look something like this. We got to do some long division here. We got to do long division because we have a x squared term. First thing I'm going to look at is how do I get from x squared to 4x to the fourth, and that's going to be 4x squared. I'm going to multiply that down. We get 4x to the fourth. 4x squared times 2 is 8x squared. That happens to fit under my next term. Okay, 8x squared. Subtract. We get 0. Negative 2x squared. How do I get from x squared to negative 2x squared? That's times negative 2. Negative 2 times negative 2x squared is going to be negative 2x squared. Forgot to bring my plus 12 down. And negative 2 times positive 2 is going to be minus 4. When I go to subtract those, we get 0, and then we get 16. That's my remainder. So I'm going to write plus 16 over x squared plus 2. Is x squared plus 2 a factor? No, we had a remainder. Now I've got to do another division problem. In this case, we can use synthetic because I'm dealing with a linear simple term. So you've got negative 6. I've got 4, 3, 2, 1 number. All my powers are there. I don't need any placeholders. 1, 6, negative 1, 12, and 18. First one down, 1. Negative 6 times 1 is negative 6. 6 plus negative 6 is 0. Negative 6 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 6 times negative 1 is positive 6. 12 plus 6 is 18. And then negative 6 times 18 is going to be a bunch. That's going to be negative 108. When I add those two together, I get negative 90 is my remainder. So I'm going to actually just move this down below here. So we're looking at negative 90 over x plus 6. Then we're going to have plus 6, no x term, minus 6x. Why am I even looking at that row? I'm going to backtrack a second here. So we did that. Now we need plus 18 minus 1x. Okay, now we're doing okay. No x squared term here, and we have an x to the third. So I could put 0x squared if I wanted, and that's okay. Is negative 6 a 0? We have to process that for a minute. So if x equals negative 6 is a 0, that means that x plus 6 is a factor. This is the connection that you need to be making here. Something is a 0 if x plus that number is a factor. I'm sorry, x minus that number is a factor. When we divided by x plus 6, it was not a factor. It came out with a remainder. So x plus 6 is not a factor. Therefore, x equals -6 is not a 0. Now we're on to some special factoring. Given that this is in the special factoring section, things are going to factor nicely. First option is probably going to factor by grouping. If you have something cubic, I want you to check factoring by grouping first anyway, because it's the easiest, fastest way to do something. So let's see if this factors by grouping. I can take an x squared out, and I get x plus 5. And then for my next pair, I can take a -4 out, and I happen to get x plus 5 left over. That leaves me with x squared minus 4 times x plus 5. X squared minus 4 can factor further. It's difference of two squares. That factors into x plus 2, x minus 2, and x plus 5 can just kind of sit there. That is factored completely. For my next guy, I'm looking at something that, well, I guess this is quadratic form. We got 6, which is twice as big as 3, and then I got a number at the end. So I guess let's try this. I'm looking for things that are going to multiply to -100 x to the 6th, and I'm going to add up to 15 x to the 3rd. Okay, things that multiply to -100, that's like -100 times 1, that's way far off. -2 times 50, nope, still way far off. 3 doesn't work. -4 times 25, well, if I add those, I get 21. We're getting closer. -5 times 20, and I add those up, I get 15. Okay. So x to the 6th minus 5x to the 3rd, I'm keeping that power for this part, plus 20x to the 3rd minus 100. All right, let's see what we get from this. I can take an x to the 3rd out, and we get x to the 3rd minus 5. I can take a 20 out, and I get x to the 3rd minus 5. X to the 3rd minus 5, and x to the 3rd plus 20. There are some special factoring patterns for perfect cubes, difference in sum of cubes, but 5 and 20 aren't perfect cubes, and we're not going to go there. They're formulas. They're not actually all that useful. And again, they're formulas that don't really have some connection in the world that we're used to. On to the rational root theorem. Part A, we got to write down all possible rational roots for this, and we've got -21 and a 1 out front. So I'm going to have plus 1 minus 1. That's going to go with plus 21 minus 21. I kind of like writing these separately, so that way as I try them, I can cross them out pretty easily. 2 doesn't work. Plus 3 minus 3, and those go with plus 7 minus 7. Okay. Completely factor. That means I have to try some of these roots out. I tend to work from the middle, so I'm going to try plus 3 first, and that means that we're really dividing by x minus 3. I like putting that at the end to remind myself what we're dividing by. 1, 5, -17, -21. Okay, bring the first one down. 3 times 1 is 3. 5 plus 3 is 8. Then we got 24. That's going to be 7 and 21, 19. Positive 3 does not work. Let's try -3. -3. 1, 5, -17, -2. Bring the 1 down. -3, 2, -6, -23. And then we get positive 69, and that definitely does not work. So we get 67 as an answer. Okay. I don't know. Maybe try 7. So that's going to be 1, 5, -17, -21. 1, 7, 12, 84. Uh-oh. This is growing way fast. This one's not going to work either. All right, how about negative 7? I'm going to scroll out so I have some more room. 1, 5, negative 17, negative 21. 1, negative 7, that gives me negative 2. 14, that gives me negative 3. And 21, that gives me 0. Phew! That means that x plus 7 is a factor. So that's x plus 7, and then this gives me x squared minus 2x minus 3 is equal to 0, which is interesting. And I'm going to have to go back and take a look at something because I think I did something wrong. And by doing something wrong, I think I wrote negative 2 instead of negative 21 way back at the beginning, and that should have been 0, saving me a lot of trouble, but that's okay, because we got to see what happens if you don't get something for a few times in a row. X squared minus 2x minus 3 factors into x minus 3 and x plus 1. This is my final factored form. Okay, that's part B. Part C is to list all the roots of f of x. X equals negative 7, that's from the first one. X equals positive 3, that's from my second one. And x equals negative 1 is from my third one. Those are the roots. Rational root theorem again, we're looking here at another polynomial. I'd like you to try factoring this by grouping first. I'm going to tell you that it won't work, but sometimes it will, and that'll save you some trouble. All right, part A, possible rational roots. We're looking at factors of 28 divided by factors of 1. Since that's a 1, I don't have to have any fractions there, which is nice. So we're going to have plus 1, minus 1, plus 28, minus 28, plus 2, minus 2, plus 14, and minus 14. 3 doesn't work. 4 and minus 4 goes with 7 and negative 7. 5 doesn't work, 6 doesn't work, and then we're up to 7. Okay, let's go to Factorland. Again, I like to start in the middle. There's no real good reason for that. I just feel like that's a method that's worked for me in the past. So 1, 2, negative 31, and 28. Let's see if I can avoid skipping numbers this time. 4 times 1 is 4. Then we got 6. That's going to be 24. Negative 31 plus 24 is negative 7. 4 times negative 7 is negative 28. And on the first try, like a champ, that means that we got x minus 4. And this guy is going to be x squared plus 6x minus 7. That's factorable into x plus 7 and x minus 1. So my part B, factor completely, is done. Part C, I need the zeros. X equals 4, negative 7, and positive 1, the three things that make those parentheses equal to 0. Those are my roots. Okay, and last up we got some rational exponents and radical stuff. For some reason this won't show up when I import the PDF, so I'm just going to write it out. First thing I'm going to do is distribute my exponents just like I did before. So we get 3 to the negative 2/3, x to the 3 times negative 2/3, and then x to the 6 times 1/7. Okay, I'm going to simplify this, and that's going to end up being 3 to the negative 2/3. 3 times negative 2/3 is going to be x to the negative 2, and 6 times 1/7 is going to be x to the 6/7. Okay, these guys get added together, so I'm going to rewrite this as 3 to the negative 2/3, and x to the negative 2 plus 6/7 would be negative 14 over 7 plus 6 over 7. So we've got 3 to the negative 2/3, and then x to the negative 8/7. We can get rid of those negatives by rewriting this as 1 over 3 to the 2/3, x to the 8/7. And at that point, you can call it a day. Same type of setup here. I'm going to take my numbers first. That's going to be 1/7. We've got x to the 1/2 minus 1/3. I'm going to rewrite that as x to the 3/6. That's the same thing as 1/2 minus x to the 2/6. That's the same thing as 1/3. Y to the 1 minus -4 is 5. That one I don't have to deal with. Then we've got z to the -8/5 minus -5. I'm going to rewrite -5 as 25/5, so we have a common denominator. Okay? Simplifying, we got 1/7. 3/6 minus 2/6 is 1/6. Y to the 5, and then we've got -8/5, and that's plus 25/5 is going to be z to the 17/5. I could leave it like this, or I could rewrite this as x to the 1/6, y to the 5th, z to the 17/5, all over 7. All right, I've got to convert this to exponential form. We know this is going to end up as x plus 6 on the inside, and I've got to make some kind of a fractional exponent. The index goes in the bottom, and the power goes on the top. This becomes the quantity x plus 6 to the 5/4. And we're done. And I've got to write this as a rational exponent. We're going to end up with ab squared on the inside, and I'm going to make some kind of a fractional exponent. The index goes in the bottom, and my exponent goes on the top. So the quantity ab squared to the 3/7.